Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.4, day 4, entitled Rational Expressions. And since this is the last section of section 1.4, we're going to talk about rationalizing the denominator and the numerator and avoiding some common errors in rational expression problems. So when we rationalize the denominator or the numerator, basically, this is where we have to get rid of any radical that's in the denominator or the numerator. And to do that, we multiply by the conjugate. And when you multiply by the conjugate, it's basically the same terms as your original problem, but you change the sign. So if it was, like they have here, if they have a plus b square root c, then your conjugate would be a minus b square root c. So the terms stay the same, it's just the sign between them that changes. And the way this works is because when you FOIL out terms that are the same but have the opposite signs, when you multiply the a and the a, you get the a squared, and then you get a negative ab square root c. And then when you distribute here, you get a positive ab square root c. So those terms are going to cancel each other out. And then a square root times itself is going to be that radicand. So when you multiply by the conjugate, you're basically distributing and canceling out those radicals, and those middle-like terms will cancel. So we have two examples here. For example 9, we have part A and B, and in both of these we're going to rationalize the denominator. And again, this is a concept that you're familiar with from Algebra 2. And so for the first problem here, I'm going to want to get rid of this radical in the denominator. And to do that, I have to multiply by the conjugate. So multiply by the conjugate. That's what we're going to be doing here for these. So my conjugate is going to have the same terms. It's going to have the 1 and it's going to have the square root 2, except I changed the sign from a plus to a minus. And I'm going to multiply it by that in the numerator and the denominator. So this denominator, we want to think of this 1 plus the square root of 2. Think of that as one whole term there. So in the numerator, we're distributing the 1 basically, but that's just going to be a 1 minus the square root of 2. And in the denominator, I'm going to FOIL. So 1 times 1 is 1. Then I'm going to get a 1 times a negative square root 2. So that's a 1 square root 2 minus 1 square root 2. Then I get a 1 times a positive square root 2. And then I'll have the square root 2 times the square root of 2, which is going to be the square root of 4, which is 2. And then it was a positive times a negative, so that's a minus 2. And again, this is why we do this, because these middle terms here in my denominator are going to cancel out now. So you don't have to write in that step where you're showing those terms. If you know that they're going to cancel, save yourself some work and just skip over that part. So my numerator now, if I simplify, will be 1 minus the square root of 2. I can't simplify that anymore. But my denominator now is going to be 1 minus 2, so that's going to be a negative 1. And you can leave it like that, or you could bring the negative up to the numerator. Usually we don't leave negatives in the denominator. We bring the negative out front. So you could have negative 1 minus the square root of 2. Your book might also distribute that negative and write it as negative 1 plus the square root of 2. Or they might flip-flop it around and put the square root of 2 minus 1. Usually it's bad to do that though, because sometimes people might think that negative 1 or minus 1 is still underneath the radical. So that's probably not the most preferred answer. I think either this one or this one would be preferable. Okay, so part B is very, very similar. We have addition again, so that means in my conjugate, in the conjugate of my denominator, I'm going to have the square root of x and the square root of y, but I'm going to change from addition to subtraction. And again, in the denominator, I'm going to think of this whole denominator as one term so that I can distribute or FOIL it to the square root of x minus the square root of y. So my numerator, when I distribute the 1, just gets me square root of x minus square root of y. Okay, now here, this time, I won't show that middle step. Okay? Here when I FOIL, I'm going to have the square root of x times the square root of x, so that's just x. Then I'm going to get the square root of x times the square root of y, so it'd be negative square root of xy. Then I get a positive square root xy. So that's what my middle terms that are going to eliminate. So I'm not even going to write that step down now. And then my last term is going to be my square root y times square root y, which will be y. And it'll actually be a negative y or minus y. And that's actually all I can do on that problem. There's nothing else that I can simplify. Okay, for example 10, this is where we're going to rationalize the numerator. This is similar to the problem that you saw on your quiz, and it's a very, very similar process. The radical this time is in the numerator, and for whatever reason, we don't want it in there anymore. So we want the radical out of the numerator now. Now this radical looks a little more complex. It has a 1 plus h in it. That's not really going to affect us right now. It might affect us later after we do the multiplying by the conjugate. Multiplying by the conjugate. That's still our process that we're going to use here to simplify this. So our conjugate then is still going to have this radical, and it's still going to have the 1, but I'm going to change this minus to a plus. So I'm going to multiply by 1 plus h inside my radical, and then minus 1. And again, this is written a little funky. Got to be careful here not to include that minus 1 underneath the radical. Okay. And then I'm going to distribute, like I did before. Everything in this numerator, I'm going to think of it as a collective term so that I can FOIL and distribute in the numerator there. So when I multiply the square root of 1 plus h times the square root of 1 plus h, I'm just going to get 1 plus h. Because the square root times the square roots cancel out. So you just get that radicand. Then I would have a negative square root 1 plus h. And then, oops, I'm sorry, I needed to change my sign here from a negative to a positive. There we go. That's better. That's a proper conjugate now. Okay, so now I'm going to have a positive square root 1 plus h and then a negative square root 1 plus h. Now they will cancel. And then since they cancel, I'm not going to write them down. And on my last term there, I'm going to have a minus 1. 1 times 1 is 1, and then I have a minus 1 since the sign was negative. And my denominator now is just going to be h times the square root of 1 plus h plus 1. Okay, now in my numerator, I'm going to have this 1 and this 1 minus 1. They're going to cancel each other out, basically. So I'll have an h over h times square root of 1 plus h plus 1. And actually, those h's are going to cancel too. So that's gone and that's gone. Now this is where a common error occurs. Sometimes students think when they cancel everything out from the numerator, it's just a 0, or the denominator just kind of pops up to the numerator. Both of those are incorrect. Remember, if you're canceling those h's, it's like you're dividing everything by h. So h divided by h is 1. So you have 1 left over in your numerator. And then in our denominator, we'll have the 1 plus h in the radical, and then the plus 1. And I can't cancel the 1's. I know I have a 1 in the numerator and a plus 1 in the denominator, but I can't cancel them because of that addition. And I have to make sure that I put a restriction on my domain for this problem. Because I have this square root of 1 plus h in the denominator, remember, we can't have anything inside that radical that's going to give us a negative number. So the stuff inside that radical has to be greater than or equal to 0. So really, any h value has to be greater than or equal to negative 1. So that would be my domain for this problem. I would have all the h values such that h has to be greater than or equal to negative 1. Okay, now in your book, it has this chart of some correct and some incorrect properties. It has the correct multiplication properties for radicals listed, and then it also has some common errors with addition. So you can look those over. A common thing that you want to do with multiplication is make sure that you are squaring both terms, or you're kind of distributing that exponent. When you have a big radical, remember you can break it down into two separate terms. When you're multiplying fractions, remember you multiply across the top and the bottom. When you're canceling a fraction, make sure you're canceling from top to bottom. And for the addition, some common errors, a lot of times when students have the parentheses and the two terms inside the parentheses are being added, they still want to distribute that exponent to each term individually, but that's not actually correct. Remember, we need to rewrite that as a plus b times a plus b. And for the second one, you cannot break apart addition within a big radical. This one here, this third one, this is a real common misconception. Students think that those squareds and the square roots will cancel each other out, which they would if there wasn't that addition between the two terms. So that expression actually can't be simplified anymore until you know the values of a and b. For this fourth one here, remember when you're finding a common denominator for your fractions, you should be multiplying here, not adding. And this one is also another common one that students abuse, I guess. Students think that because there's an a in the numerator and an a in the denominator, they can just cancel the a's. That's only true when there's multiplication. You can cancel when there's multiplication, but not when there's addition between the terms. And as we're going through any of these problems, remember you can check your answer. You can substitute values in to check your answers. And they just show an example here where if you take the fourth error from the previous page and you substitute in 2 for A and 2 for B, if you have the 1 over A plus 1 over B, you would end up with 1. And if you had the 1 over A plus B, that would get you to 1/4. So just by doing a simple substitution, you can see that these two concepts are not actually the same value. So there is your practice set of problems for you to work on. If you have any questions, come on in before school and see me. Good luck. Do well.